Caring for country in a cyclical relationship with the land and all living things is a core value exhibited by the Illawarra Aboriginal Lands Council. Their roles include, but are not limited to, land management, social housing, site works, cultural heritage, and employment. Falling under these roles is the goal to reduce the amount of waste going into landfill. This directly coincides with the ideals of a circular economy and closing the loop, a concept that is implemented in the Plastile. The Plastile was designed to reduce waste going to landfill while contributing to housing projects in the community in a sustainable way, bringing funds to the council, as well as enabling community involvement, increasing the quality of life for those in the Illawarra. The main waste stream being employed is a high-density polyethylene, otherwise known as HDPE, which is a common plastic found in domestic and construction waste streams. During the site visit to the local vinnies, it was obvious that the recycling of plastics is the biggest concern throughout the Illawarra, with only about 12% of plastics recycled in 2016. That's only 400,000 tonnes out of the 3.5 million that were consumed that year. The environmental implications of this are vast, directly affecting a number of natural resources. These implications include plastics overflowing landfills and clogging up waterways, not only using up a lot of space, but also leading to wildlife destruction. These statistics reflected the dire need for a useful, profitable product that utilized the recovered HDPE, thus our decision to create the Plastile.
The Plastile is an alternative to clay or ceramic roofing tiles. It is manufactured from HDPE and it is a very fast and simple tiling system. The basic function of the product is to cover the span of framed roofing to protect a structure. The features of the product includes grooves on one end and tongues on the other. The tongues are used to slot into the next tile, locking the system together, whereas the groove is used to channel water off the roof into the gutter efficiently. Due to the waterproofing abilities of the HDPE, this channeling of the water is done very effectively. Holes are introduced within the cross-section area of the tile during the manufacturing process to act as corrugations, whilst minimizing material used and cost of manufacturing. The main issue to address for the design is the impact of UV degradation on HDPE. The product is mixed with carbon black, which either absorb or reflect the UV rays, limiting UV degradation over time and improving the lifespan of the product. The manufacturing process of the product involves the melting of HDPE, adding sand to improve the structural properties of the product, and carbon black to provide UV stabilization of the product. The melted plastic materials are then added into the plastic injection machine. The mixture is injected into a cavity mold. It is then cooled and ejected, resulting in the production of plastiles. For the installation of the tiles, each block is placed staggered like an ordinary brick wall with horizontal steel reinforcements laid between each layer, and the lips interlock each layer of the blocks. Once laid, vertical steel reinforcements are slid into the blocks and the formwork is filled with recycled concrete aggregate mixed with cement. Thank you.
Hi, I will be talking about the life cycle analysis and risk assessment for Plastile. Life cycle analysis includes of extraction, manufacturing, distribution, consumption, disposal, and end of life. We plan on extracting HDPE from landfill or skip at White Gully. The transport of HDPE will produce about 7,800 kilograms of carbon emission per year and will be extracting about 2,800 tons of HDPE in a year. The manufacturing process includes of melting and injecting HDPE into molds. This process will consume about 112 kilowatt-hour per day of energy, and we will be saving about 54 gigajoules of energy per ton. Plastile consists of 64% of HDPE, 30% of sand, and 6% of carbon black. Our product will be marketed to construction sites, government projects, and professional tradesmen. For the disposal of HDPE can be recycled at least 10 times, and there's many waste management companies in New South Wales who will be happy to recycle and process HDPE from us. Now, talking about the risk assessment can be divided into two parts. which can be the manufacturing risks and operational risk. The manufacturing risk is mostly involved with machinery, as we will be using a lot of machines with manufacturing and processing of plastile. For instance, melting machine produces a lot of fumes which are not toxic, but at the same time they can cause respiratory irritation if inhaled. We can overcome this by providing face masks to all the workers who are working with this. Also, we need to be very careful about the machines. Machines need to be in their best working conditions, as most of the risks at the workplace are involved with machines. The operational risk include of transport and installation and the physical state of workers. The transportation risks are mostly the road accidents. Installation risk can be classified as person who's installing the roof tiles and faces some kind of injury by slipping and falling down or something like that. So that's all. Thank you.
Thanks, Ahmad. So based off those life cycle analysis stages just outlined in the last section, we were able to come up with costs for each of those, comparing our processes with similar manufacturers. So we were able to come up with capital costs, such as the cost of machinery and vehicles required for our process, and we're also able to come up with the operating costs, such as the lease of our warehouse, power, labour, water, fuel, as well as the cost of materials required to produce the product. Now, our estimated cost for the Plastile per square metre, including a $20 markup, is $76.35 per square metre. Okay, now we were estimating a rough turnover of approximately 31,500 square metres per annum, which will divert approximately 2,600 tonne of plastic from landfill. Now, in factoring in the $20 markup, we are estimating an approximate $450,000 revenue per annum. That's after tax. Now, if we apply our 4% discount rate to that, we were able to forecast that and calculate our NPV. So on this graph, it shows our cash flow per annum over the 10-year project. And as you can see, we do break even within the first financial year. Okay, so in conclusion, the Plastile is going to be manufactured locally, so it will create jobs in the local area and also provide a reliable source of income for the ILALC. And furthermore, it will reduce the cost of construction materials locally, which will then improve the ILALC's ability to provide those key services such as social housing, government infrastructures and facilities, and then improve working towards financial independence within the area. Thank you for listening. That's the Plastile.